All right, this is going to be our presentation on section 8.4, which talks about special parallelograms. And the special parallelograms we're going to be focusing on today are rhombuses, rectangles, and squares. So here we go. So at the top there is parallelogram, and the characteristics of parallelogram there at the top of this chart. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So those are some of the characteristics of parallelogram. And then we've got some special parallelograms. We've got the rhombus, the rectangle, and the square. So taking a look first at the rhombus, characteristics of the rhombus are the diagonals are perpendicular, so there's a 90-degree angle formed inside a rhombus when the diagonals cross. And then the diagonals actually bisect the angles of the parallelogram. So that's kind of an interesting deal there. Over here, I've got the rectangle. The characteristic of rectangle that adds from parallelogram is just that the diagonals are congruent. So on a regular parallelogram, the diagonals are not congruent. They just bisect each other. But on a rectangle, the diagonals are actually congruent to each other. And then we move down to square, and square does everything. Square, the opposite angles are congruent, the opposite sides are congruent, the consecutive angles are supplementary, the diagonals bisect each other, diagonals are congruent, diagonals are perpendicular, and diagonals bisect the angles. So square is super special. It does like a lot of stuff. So we're going to get more in depth into each one of these figures. So here's the rhombus. So a rhombus is just basically an equilateral parallelogram. All the sides are the same. So again, because it is a parallelogram, the diagonals bisect each other, um, just like they do on a regular parallelogram. The opposite sides and opposite angles are congruent. And then in addition to that, the intersection of the diagonals inside there is a 90-degree angle. So this is a 90-degree angle that's inside of this rhombus here. And then this is more just anecdotal information. So if you took a ruler and tried to make a rhombus, you can actually make one. So if you take a ruler and cross lines on the top and bottom side, and then just flip the ruler a little bit and then cross again and draw lines, you're going to make a rhombus inside of that. So as long as you've got a regular ruler, you can make a rhombus. So that's more just kind of information for you. So let's take a look at some values inside of here. So you've got a rhombus here. You'll notice I've shown a value of WV at 7. And because one of the characteristics are diagonals bisect each other, then I would know this number is 7 as well. And that would make WY here, this entire length here, 14. So that's one of the things I can get out of the way right off the bat. So WY is 14. And then let's take a look at angle WZV. So angle WZV is this angle right here. So because on a rhombus, diagonals actually bisect the angles, because this angle is 34 degrees right here, that makes this angle here also 34 degrees. And that makes angle then WZV 34 degrees. All right, taking a look at measure of angle XYZ. So I'm going to take a different color. Angle XYZ. That would be this entire angle right here. And because angles are supplementary in a parallelogram, not even just a rhombus, but just in any parallelogram, if I take 180 degrees and I subtract any one of my consecutive angles. So if I subtract this angle Z here, and the measure of this angle is actually 68 degrees, because if I take those two 34s and add them, and subtract 68 degrees, okay, that's going to leave me then with 112 degrees. So this is 112 degrees then, angle X, Y, Z. And then on the measure of angle WVX, so angle WVX, I'll change the color there. WVX is this angle, and as we said before with a rhombus, diagonals are perpendicular inside on a rhombus. So this is a right angle, so this is a 90-degree angle. So that finishes up these calculations for the rhombus. Okay, so a couple of questions here. So a rhombus, any rhombus, A, B, C, D, determine whether or not the following is sometimes true, always true, or never true. So these are one of my favorite types of questions and ones that sometimes students will struggle with. The easiest way for me to do that is just make a rhombus. Make a rhombus. So just make and I'll just use the one that's right here. B, C, D. And I could have started this at any spot as long as I keep going in consecutive order. I could have started here, gone A, B, C, D, and make it that way. And then I can more easily visualize this. So angle A and angle C, these are opposite angles. So in this case, these are opposite angles. So this one is always true. I gotta find an easier way to type that, I'm sorry. And then taking a look here, segment DA and segment AB. So segment DA would be this one, and segment AB would be this one. And on a rhombus, all the sides are the same. So in this case, this is also always true. So both of these are always true. All right, let's take a look at the rectangle. So the only thing the rectangle adds to parallelogram basically is the diagonals are congruent. So in this case, the diagonals, segments that connect non-consecutive vertices, so this one going to here is going to be equal to the length of this one going to here. So that's the only thing that's really added in rectangle. Notice diagonals are not perpendicular, so there's no 90-degree angle here like on a rhombus. But another, I guess, interesting piece of information is that there's two sets of congruent isosceles triangles. So this triangle and this triangle are congruent to each other, the top and bottom ones. And then the left and right triangles that are inside here are also congruent to each other. So that's kind of an interesting deal there. So let's take a look at some values here. So first thing I'm showing you here is that QS is 18. So if QS is 18, then that means that these diagonals are getting cut in half. So that makes this one 9, this one 9, and then because on a rectangle, diagonals are congruent, this one is 9, and this one is 9. So if I go here and just take a look at ST, segment ST is going to be 9 units. And then segment PR is just going to be 9 and 9 added together, so 18 units. So this kind of finishes the easy part of this, which is finding the segment lengths. Now let's take a look at angle PQR or QPR. So angle, I'll pick a different color here. Angle QPR, QPR is this angle right here. All right, and because rectangles have 90-degree angles, I'm just going to take 90 and subtract 62 from that. And when I take 90 and subtract 62, I get 28 degrees. So that's just 90 minus 62. And then angle PTQ. So I'm going to change that color again. So angle PTQ is this red angle. So as I told you before, there's 4 isosceles triangles inside of there, which means because I have 2 sets of congruent sides, I have 2 sets of congruent angles. So if this one here is 28 degrees, then I've also got 28 degrees inside of here. So in order to figure out angle PTQ, I'm going to take 180 degrees and subtract this 28 and subtract that 28. And 180 minus 28 is 124 degrees. So I hope I didn't go too fast for you on that one. All right, so the square. The square does everything. All angles and sides are congruent on a square. Diagonals bisect each other. Diagonals are perpendicular. Diagonals are congruent. And then inside a square are 4 sets of congruent isosceles triangles. And not just any kind of isosceles triangles, but right isosceles triangles. So this is right isosceles, this is right isosceles, this is right isosceles, and this is right isosceles. And they're all congruent to each other. So a square is pretty cool. It does a lot of awesome stuff. So let's take a look at some values here. So I've given the value here that JG is 15. So if JG is 15, that means all the other diagonals inside of there are all 15. So this is 15, HJ is 15, JF is 15. So if I do the diagonal lengths first, so if I'm looking for FH, FH is the entire length of this diagonal. So this one is 30 units. And then EJ is just going to be 15. So let's take a look now at angle EJF. Angle EJF, so I'll change the color. Angle EJF is this angle right here inside. So because it's a square, that's automatically a 90-degree angle. And then taking a look at angle JFG, so I'll change the color there. Angle JFG, that's this little guy right here. Okay, that angle then is going to be 45 degrees. So if I take a 90-degree angle and divide it by 2, that becomes 45 degrees. So angle JFG is 45 degrees. All right, we can move on. All right, last part of the slide, and kind of one of the most difficult ones to do. I found that students really struggle trying to figure out these figures. So you got to look at everything here. You're looking at is going to be the diagonals. So in this case here, the diagonals are bisecting each other, and the diagonals are not the same as each other. So this diagonal here is a lot longer than this diagonal, but they are coming together at a 90-degree angle. So that makes this a rhombus. Looking over here at this one, the only thing you're told is that the diagonals are bisecting each other. So this diagonal gets bisected, this one's getting bisected. So there's nothing else special that's going on here. So in that case, this is just a parallelogram. Now we've got over here, we've got that 90-degree crossing of the diagonals, but notice all the diagonals are congruent to each other. So because they are crossing at a 90-degree angle, and because they're all congruent to each other, this is our square. And then moving over to this one, because I already told you it was parallelogram, okay? And because I've marked some congruency parts here, and opposite sides on a parallelogram are congruent. So this side opposite this one is the same, and this one opposite this one is the same. That means we've got yet another rhombus. So that's it. These are the assignments that are going to go along with this presentation. And for the first day, I want you to just do 1 through 14. On the second day, just 15 through 24. Third day, do 32 through 37. And then the fourth day, do 38 through 41. And then 44 through 48. And then the fifth day, just do the quiz on page 534, 1 through 6. And that concludes the presentation on section 8.4. Thanks, and have a great day.